Welcome to Solutions Studio. This is a free series on C programming language. If you like these videos, please subscribe to follow along with this series. Also, please like and leave a comment and share the video to help spread this series. Hello and welcome to this episode, and in this episode we have a few examples for using the for statement and especially the control variable and how we're going to manage the control variable. Let's go and see our first example. The first example wants us to start from a value of 1 and to reach until 100 with increments of 1. This is pretty obvious. We start from 1, the initialization of the counter is 1. The condition wants us to reach 100 and the increments are one step at a time with 1 added to the counter each time. The second example wants us to start from 100 and to come back to 1 with a decrement of -1. And this is also the same way. We initialize with 100. The condition tells us for the I to be greater than or equal to 1. And you can see that we have the decrementation operator used for each decrement of -1. The third example tells us to start from 7, go to 77 with increments of 7. So the initialization will be the start of the control variable 7. The condition tells us where to end, and also we specify the increments. The fourth example is again a decrementation from 20 to 2 with decrements of -2. We start from 20, we reach until 2 with decrements of -2. You can see that this is a minus and this is a 2 and this is an assignment statement. The next example, which is a bit more interesting, is telling us to start from 2, go to 5, 8, 11, 14 and 17. Now, what is the incrementation between each of these values? You can see that between 2 and 5 there is 3, between 5 and 3, between 5 and 8 there is 3, between 8 and 11 there is 3, so the incrementation must be +3. So we start with an initialization of 2. The condition tells us to reach us until 17 and with each +3 increment. Now the last example wants us to create this sequence 44, 33, 22, 11 and 0. Now you can see that the difference between each of these values are 11 units. So 44, 33, 22, 11 and 0, each one of them, there is an 11 decrement between each one of them. Now we start with an initialization of 44. We reach until 0 with the condition, and with a decrement of -11 we will reach each of these values. I hope this has helped you a little bit more on understanding the control variable in a for statement. Stay tuned as we go into more details of a for statement. Hello and welcome to this episode, and we are trying to have an exercise using the for loop. Now our exercise and example is telling us that start from the integer 2 and go until 100 and add all of these numbers from 2 to 4 to 6 to 8 to 10 until 100. Add one of them to one another and print the result. Now let's go and start working on this program and try to solve it. Now the first step is to initialize a variable called sum to store the sum of all of the numbers that we will go through from 2 to 100. Next we are going to create a for loop which will start from 2. So I will say integer number is equal to 2. It will go until 100. Then I will say that number should be less than or equal to 100. And the increments are number added to 2 each time. Now the for statement has started. What I want to do inside the for statement's body is that to add sum with number each time. Now initially number is 2 and it's less than 100. Then what's going to happen is that this 2 is going to be added to sum. Then the for loop will do the incrementation and make the number 4. Once we have got 4, we check the condition once again, it's less than 100. Then 4 is added to sum and the incrementation happens once again. Now it's 6 and 6 is less than 100 and the addition happens to the sum, and this cycle will continue going on until we reach 100. And that's it, we have got the final value of our sum after the end of this for statement. Let's go and print this value. And let's go and execute this program. We have made a mistake in here. What is our mistake? Let's have a look. Printf, supposed to be printf. Now this is the value that we got. It's the summation of 2 until 100. And that's it for this episode. I hope this has been useful for you, and I will see you in the next episode where we will be doing more examples for iteration statements. Now let's go and create this problem. As you can see here, I have included another library which is called math, because we will be using some of the functions from math library in our program. Now I have defined two variables, one to store the amount of principal and another to define the interest rate. Using this printf statement, I'm going to print the header for the output of this program. We will go into details of this part later on in the coming episodes. Now let's go and analyze this for statement. We said that our program will print the result for 10 years. That's why we have started from 1 and we will go until 10 and we will increment for each year. The amount of money that we will get after adding the interest rate is that this amount is equal to, using this formula, principal, which is the original amount, times 1 added to the annual rate, and all of them, and this expression to the exponent of n years. Now this function will do that. This function will raise this statement to the power of this value. And this function belongs to the math library, which we will cover on later in a bit more details in the coming episodes. Finally, we print our results using a printf statement, which I will go into more details of this printf statement in the coming episodes. Let's go and run this program. Okay, we've made a mistake. Okay, we have forgotten the semicolon in here. Let's add the semicolon. Now you can see that we've got the amount on deposit for each year. The first year and second and third and going on until the third year. That's it for this episode. This was another example of for iteration statements. I hope you've got a better I hope you have been able to get a better understanding of for iteration statements. Stay tuned and we will go into more details of this program in the coming episodes. Hello and welcome, and in this episode we discuss some formatting of numeric outputs and especially floating point numbers. In the previous episodes we had a line like this where we wanted to print the year and the amount of interest for our calculating of the interest program. But now in this program, in this example, I have changed it a little bit. The value of the variables I have changed a little bit, but you know that in the previous episode we saw that we had this conversion specification for the floating point number, which was amount, and this conversion specification includes a percent sign, 21 dot 2 if. Now you know what if exactly means. That is a floating point number. You know that dot 2 means that it will be printed with a precision of dot 2 floating point numbers. Now what does exactly this 21 means? This 21 in the conversion specification, it means that the value will be printed with a field width of 21. What does exactly a field width means? A field width of 21 means that 21 character positions will be used to print the value. Now let's go and run this program and I will show you all that 21 character positions that was used by this variable amount. Let's make these comments. And now we can run this program. Now you can see that this is the variable that we had. It's a floating point number 100.12. Now let's go and calculate the amount of field width that was used for this variable. It starts from here: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 and 21. As you can see, it has got a field width of 21. Because the number of digits for this variable was smaller than the field width, that's why we have all these spaces in the right side. Imagine if we wanted to have it on the left side, then what we can do is that put a minus in here, and all that space will actually go to this side of the variable. You can't really see it, but it does exist in here. If I, for example, try to put something a little bit more after F, then you will be able to see it. You can see that we have all these empty spaces because of the field width. And that's it for this episode. I hope that you have understood what is exactly a field width. Thank you for being with me in this episode, and I hope to see you in the next. In this episode, we are going to discuss about floating point number precision and memory requirement. You know that in the previous episodes, we have used two kinds of variables. One was float and the other was double. Now I want to tell you the difference between float and double. So float variables usually take up to 4 bytes of memory and they have about 7 significant digits. 4 bytes of memory is about 32-bit. But the variable of the type double usually takes up to 8 bytes of memory and they have about 15 significant digits and they can store 15 significant digits, which is twice as much accuracy as float variables. 8 bytes of memory is about 64-bit. And most programmers use double in their programs, and double is more than enough for many applications. Also remember that by default, C treats floating point numbers like this number as a type double. In the source code, these values are called floating point literals. Also, it's important to know that we have a longer type of variable which is called long double, and it takes about 12 or 16 bytes of memory, but it's not very common to be used in our programs. Here we talked about significant digits. Now I have a few examples of significant digits for you. It's not a discussion to be discussed in here, but I have put some examples for you to understand what a significant digit is. So at the end, we can conclude that basically for floating point numbers, we can define them either as float or as double or as long double, and each one of them, they have their own memory requirement, and each one of them can store different number of significant digits. That's it for this episode. I hope it has been useful for you, and I will see you in the next episode. Hello and welcome to this episode, and in this episode we discuss a few things that you have to be careful about displaying rounded values. So as we said before, that floating point numbers can cause trouble sometimes. Now we want to have a simple explanation for you of what can go wrong when floating point numbers are used to represent dollar amounts with 2 digits to the right of the decimal point. Suppose that we have bought 2 items from a store, and these 2 items, they have $2 amounts. These $2 amounts that could be calculated and stored in the machines are 14.234, and they are rounded to 14.23 for display. And the price for the other item is 18.673, and it has been rounded to 18.67 because of display. And when you add these amounts together, or the machine adds these amounts together, you get an internal sum of 32.907. This number is usually rounded to 32.91 for display. Now the machine in the store will tell the user to pay this amount, although when the user calculated the amount, he found out that he has to pay like 32.90 cents. Now this could make a problem because the user might assume that the store is charging them more. But it's not that the store or the machine is charging them more, it's rather that there is this danger with rounded values. So rounded values are always approximations, and with approximations we could have such problems. And maybe some people who do not understand the math behind rounded values properly, they might get mad and they might assume that they are being tricked. So always remember these points about floating point numbers in your applications, and be cautious about these kind of errors. These kind of errors are also called representational error. So it's a good keyword that you can memorize. And that's it for this episode. I hope to see you in the coming episode.